Hello and welcome to this recording about process costing. You will be familiar with job costing, where we work out how much it costs to produce a single job. We've also looked at batch costing, where we work out how much it costs to produce a batch of items. In both job costing and batch costing, there is a definite start point, which is the start of the job, and an end point, which is when we finish the job or finish the batch. Process costing is slightly different in that we are producing products continuously, so there is no definite start and stop point. However, we still need to be able to calculate how much it is costing us to produce a unit of our product, and that is what we were going to be looking at today. Examples of process costing would be within the chemical industry, the brewing industry, mining, or perhaps one that you're more familiar with, the chocolate industry, where chocolate is being produced on a continuous process. Now within process costing, what you will see is the input into the process, which will be the materials, the labour and the overheads, and then the output from the process will be your finished items. In addition to that, you will come across normal losses and abnormal gains. The nature of process costing often results in the output not being the same as the input in terms of quantity. So we may have input 1,000 kilos into the process, but the output from the process may not weigh 1,000 kilos. It may be less than 1,000 kilos. If we expect this, then that's known as a normal loss. So it's the loss that we expect from the production process. This could be because we've drawn off some of our product to inspect it or to test it for quality. It could be in the case of something like chocolate, where the liquid chocolate, when it's poured into the moulds, we maybe lose some of that liquid chocolate due to dripping, or simply that some of it remains within the mixing bowl. So these losses that we know about are referred to as normal losses. There are also losses that we don't expect, and these are referred to as abnormal losses. So this is a loss that is over and above the normal loss. We can also come across abnormal gains. Now this does not mean that we are actually gaining in output, but it means that we have not lost as much as we expected. Now we need to put valuations to our output, we need to put valuations to our normal loss, and we need to put valuations to our abnormal losses or gains. So starting with the normal loss, there are only ever two valuations for a normal loss. It will either be 0, so your normal loss has no value, or scrap value. Now in some instances you may find that your normal loss can be sold. So it depends why your output is not the same as your input. So if we've input 1,000 kilos of material and the product that we've received at the end of the process weighs 950 kilos, so we've lost 50 kilos, If we've lost that 50 kilos due to taking it for testing for quality, then we can't sell that. If we've lost that 50 kilos due to the product evaporating, then we can't sell that. So those losses would be valued at 0. However, if we go back to the example of chocolate, if our output is 50 kilos less than our input, and that 50 kilos is due to misformed chocolates that weren't as expected, we could still sell those. Many of you may have seen misshapen chocolates for sale. We sell them at a lower than normal cost. So in questions that you complete, you will need to check and see if your losses have a scrap value. So just to repeat the valuation of normal loss, you will either value your normal loss at 0, or if it can be sold for scrap, you will value it at the scrap value. In terms of valuing your output, you will need to be familiar with this formula here. So to value our output on a unit basis, it is the process costs, so that is the material, labour and overheads that you have put into the process. So your process costs, material, labour and overheads. We deduct from the process cost the scrap value of your normal loss. So if you are able to sell your normal loss for scrap, then that gets deducted from your process cost. And then you divide by your expected output. Expected output is the quantity of material that you have put into the process minus your normal loss. Because remember, your normal loss is an expected loss. So you know from past experience that when you carry out this process, you will lose a certain amount of your input. This cost per unit formula you also use to value your abnormal loss. That was the loss you didn't expect, and you use it to value your abnormal gain. Just a reminder, your abnormal gain is where you didn't lose as much as you expected to lose. So this will become a bit clearer as we work through some examples. Now, the first thing that you should do when you are dealing with process costing is to look at what we call the physical flow. The physical flow is looking purely at what has happened with the quantities of material. So within the physical flow, we consider the amount of material that we have put into the process, and then we consider where that material has gone. So what has been the output, what has been any of the losses. So if we look at a couple of examples. So this first example, 500 kilos of material are input into the process, which cost £1,000. Labour costs £500, overheads cost £200. Now for the moment, we're only interested in the quantities. So we input into our process 500 kilos. We are told normal losses are expected to be 5% of the input. Normal losses are always expressed as a percentage of the input. So we've input 500 kilos. We expect to lose 5% of that. So 5% of 500 is 25 kilos. Now in our physical flow, it has to balance. So whatever is on the left-hand side of the equal sign must be equal to everything that is on the right-hand side of the equal sign. So we have 500 kilos on the left-hand side. On the right-hand side, we have 25 kilos. So therefore, the output from this process must have been 475 kilos. So that 475 kilos output plus our normal loss of 25 equals input of 500. So we know when we put 500 kilos of material into this particular process and produce our product will weigh 475 kilos. The 25 kilos difference is a normal loss. We expect that to happen. Now let's look at a second example. So it's saying that we assume we have the same process, but instead of losses being as expected, losses were actually totaling 40 kilos. This means we've lost more than expected. So let's have a look at that. So it's the same process, so we input 500 kilos. Our normal loss is still expected to be 5%. I would recommend that you always record your normal loss first. So normal losses are expected to be 5% of our input, so we know that is 25 kilos. The example tells us actual loss was 40. We expected to lose 25. Okay, remember your expected loss is your normal loss. So the difference of 15 kilos is your abnormal loss. So that was the unexpected loss. So we put into our physical flow the abnormal loss. It all needs to add up, so that means we can now work out what our output is. It has to be 460. So that 460 kilos plus 25 plus 15 equals 500. So you'll notice we've not actually recorded in our physical flow the actual loss. It is always split between the normal loss and then the abnormal loss, or in the next example, the abnormal gain. So again, this is assuming the same process. So we're inputting 500 kilos. Make the first thing that you record on the right hand side your normal loss. We know it's 5%, so we know it's 25 kilos. What we're told this time is that the actual loss is 15 kilos. The expected, or your normal loss, is 25 kilos. So we've actually gained 10 kilos. Okay, we expected to lose 25 kilos. We only lost 15 kilos, so we are 10 kilos better off. So in our physical flow, we now have an abnormal gain. Abnormal gains are subtracted. So we have minus 10 kilos. We've just got to rub this a little bit out here, tidy it up slightly. So we can now again work out our output. Needs to add up to 500 kilos. We've got 25 minus 10 gives us 15, so it means our output must be 485. So 485 plus 25 minus 10 comes to 500. So what you're seeing is we are dealing with our physical flow first, and it's very important that when you attempt any process costing calculations that the first thing you do is the physical flow. So write it out. So we have input is equal to the output plus the normal loss plus the abnormal loss or minus an abnormal gain. For each process there could be either a loss, an abnormal loss, or an abnormal gain. You should not have an abnormal loss and an abnormal gain in the same physical flow. So you will either write plus an abnormal loss or it will be minus an abnormal gain. So this is important. First thing you need to do, and it will then make your process costing calculations a lot easier once you have this physical flow. Remember, this is quantities only that goes into the physical flow. And when you have written it out, so write out input equals output plus your normal loss plus an abnormal loss or minus an abnormal gain, put in your input figure, then put in your normal loss figure, and then look at your other figures. If you do it in that order, then hopefully you should end up with the correct figures in there. And remember, we never actually show in the physical flow what the actual loss is. Instead, we show normal losses and abnormal losses or gains. Now, what I would suggest is that you have a look at a question in your workbook that is about preparing physical flows, and attempt that question before you look at the next video, which will be looking at how we can then put values to our physical flow and how we can record them. So please go and have a look at a question now.